Hey, in this video we'll be talking about the lifetime and scope and allocation of variables. So we'll be talking a little bit about memory, how you reference these variables, and when they can be referenced and when they're gone forever. So in Visual Studio, I'm starting off with just a Hello World program, and what I want to do is just demonstrate kind of what scopes are all about. So we work often in the main function, but we can call off into other functions, and you should probably, by this point, already be aware of the basics of scopes. So if I have some other function, and I declare a variable, right, and do whatever I want with it, my var, let's do things with it, I don't know, even print it out maybe. Who really cares what we do in this function? But this variable's scope it is tied to is the my function scope. So when I talk about scopes, usually you can think about it as the curly brackets as representing a scope. And when this variable or when execution is within this function, then this variable is in scope. And when we are out of this function, not in there, then this variable is out of scope and it doesn't really exist. It only exists within the scope of that function. And that means that other code can't reference that. So this should be kind of obvious. This will be an error because there's no such thing as myvar in the main function scope. So the nice thing though, working this way, is that variables that you set up in some scope, when the scope when they leave scope, they're gone. They're just destructed automatically. You don't have to worry about them at all. Any place that you see curly braces generally denotes a new scope. So if you have like a for loop, int I equals 0, all this stuff, whatever we want to do for our loop, the loop specifies a new scope as well. Within these curly braces, any variable that I make here is going to be only alive within the scope of this loop, and outside of the loop you can't access this a variable at all. Also, as a way that for syntax works, this I variable is also only accessible within the scope of the for loop. So this is kind of why I said the curly braces generally denote scope, but you know that there's a scope here, and this I variable, anything declared here, happens to be in that scope. So I won't be able to reference either of those variables outside of this scope. There are some programming languages that don't follow this rule, but they're pretty rare. I guess the languages themselves are popular enough, but this functionality is rare among programming languages. So something like certain specific scripting languages like MATLAB, if you use MATLAB scripting for math calculations in their environment, it has really weird scoping rules. Okay. So we've seen that the lifetime of this variable is tied to its scope, but there's a way around this. We can ask the computer to make a dynamically allocated variable that doesn't obey these scoping rules necessarily. But this is when we need to talk a little bit about the memory. So when we create an object or a variable, in a function scope like this, this variable is said to be allocated on the stack. And you can think of like a stack, like a pile of cards, right? You stack them up, and if you're only accessing them one at a time, you usually are taking them right off the top of the stack or putting things on top of the stack. And that's how a stack works in computer science, in programming. For function call stacks, all of the variables in a function are, or within a certain scope, are kind of packed together and put in one place in memory, and that's called the stack. And so if you call another function, so let me do another function here, and you have more variables in that function, then when you call that function, you're adding another stack frame. Another function, and this has its own scope where it has a more variable. And then when we leave that function, that whole stack frame is removed from the stack, and we've got the my function stack back where we were. So my var, right? We can do whatever we want. And then when we return from this function, all of these variables, whatever I have in this function, get popped off the stack, and we're back to wherever we called it from, right? Okay, so now let's try to circumvent this. The way to allocate memory on the stack is to just declare your variables as normal. That's the rule for C++. That's not always for every language. So, for example, C# has a slightly different rule for how to allocate things on the stack. And really the big question in C# you have to ask is, am I allocating something that is a class? And if it is a class, then it's not going to be on the stack. It's going to be in this other part of memory. So that other part of memory is called the heap. So we've seen some stack allocated variables. I'll just say this is stack allocated, and all the other ones we've seen so far in the video are stack allocated. But we can also make heap allocated variables. And so the stack and the heap are two segments of memory. They're segments of the same kind of memory. They're both in RAM, but they're accessed a little bit differently. Whereas the stack is really simple to access, the heap takes a tiny bit more work. First of all, if we were going to do it just with integers, then it's not too bad. But in C++, I do need to make a pointer. This is going to be like represent a memory address where this object is stored. So I'll just call this thing B, and I'll use the new operator to allocate something on the heap. So the heap is just another memory segment. It's less organized than the stack, which is probably why it's called the heap. And it allows us to just request pretty much an arbitrary amount of memory, size of memory. This is essentially the rest of our memory, the rest of our RAM, whereas the stack is usually a set size that we shouldn't exceed. So if we need big variables, then we do it on the heap. Now it's important when we're all done with a heap allocated variable that we delete it. So we can do whatever we want with the B variable, do things with B, and then when we're all done, make sure that we match every new with a delete, with a corresponding delete. So that frees the memory, make sure that we don't have a memory leak. All right, so the thing about this is since we have like setting up the variable, but then later we have to kind of free it, that means we could free it anytime later, even in a different scope. So this new integer is some piece of memory somewhere, and we can reference it through this variable b, which means we can do things like pass that variable b to a function, and let's say another function, and within that that function we can do things with b. Do other things with b. And when that function ends, well, that memory is still there. We still have this new integer. We can still mess around with it, and later we still have to delete it. So it doesn't obey those scoping rules of the function. However, technically, those rules are still being followed. This variable, int star b, is a variable. It's just like an integer storing a memory address, and it needs to store that memory address in order to access the new integer that we've allocated on the heap. And so this b variable actually does obey those rules. At the end of this function, the pointer b is going to be gone. At the end of this function, this is actually a copy of that memory address. At the end of this function, that b variable is going to be gone. And it works the same way as all of our other integers and everything. But the memory that it references, that is on the heap, and that is treated differently. And that's why we need to delete it at the end. All right, so in C++, everything is allocated on the stack. That's kind of the default until you see this new operator. This keyword new says in C++ that we're going to be allocating on the stack no matter what. Now you could see it explicitly like this, but you might also see it implicitly if you create some class, some object of a class. You could create it on the stack or the heap, but what's internal to the class decides whether it uses new internally. It could allocate more stuff on the heap if it wanted to. All right, so yeah, in C#, classes are always allocated on the heap. You'll use new as well in that language. Some other things you'll also use new, and that's why it's a little confusing going between C# and C++. In C#, it just matters if it's a class or not. To get around that, like to put stuff, suggest that things get put on the stack, you could use a struct instead of a class, and so that typically puts it on the stack, but ultimately the C# implementation is in charge, so you don't even get to be insured about that. But in C++, you're just looking for new. New is the way to tell if it's on the heap or the stack. All right, so that's all we have for scopes working with stack allocated variables. Their scope and their lifetime is tied to a function or curly braces, this scope. So the lifetime of the variable is just the lifetime of their scope. And with heap allocated values like this new int, we're going to get a lifetime that lasts until you use delete on it. And it's regardless of the scope, which is what kind of causes memory leaks to be possible. But it's also a very flexible way to pass around objects that are going to last until you explicitly say that they should be destroyed. So I've used a pointer here, but we'll talk more in a later video about how to actually do things with that pointer variable, how to access that integer. See you later.